Okay, so let's continue our lecture on example 2. Okay, so we have done with example 1 in a previous part. Okay, so right here we have different configuration of arch structure where we have different level of support of arch, and in this arch we have two types of load, which is a UDL that acting along 30 meter of arch, and point load at point E, okay, which is located 10 meter from support B. Okay, so based on these examples, we will see how we can analyze the internal forces at the 2 point, okay, so which is at a point D, okay, and at point E, okay, based on different load condition. Okay, so as introductions, I would like to highlight that at a point E, so you need to consider two conditions, okay, of internal forces, which is with point load and without point load. Okay, so where for the UDL, so you just consider condition under load only that we have seen in the example 1. Okay, so let's see the solution for this example. Okay, so as usual, you need to solve for direction, okay, of arch. Okay, so and right here you can see that they have a step where you need to find out the y, the height, and okay, the YA at the point A. Okay, the reason why you need to find out this YA is because you need to use the height of this YA in order to solve the direction in the arch. Okay, so in order to calculate the YA, okay, so we will use the general equation that I have introduced in the previous part, and you need to bear in mind that the origin point of this arch is at this point, okay, based on the complete shape of arch, not from the A. Okay, so because this equation of y is based on the complete arch, it has been derived based on the complete arch. Okay, so in this diagram, so we have a different level of support. Okay, so and you can't to consider that the origin is from A. Okay, okay, so to solve direction at support, okay, so since we have 4 numbers of fraction, okay, so you need to have 4 numbers of equation. Okay, so you can start from point B by taking a moment at a point B. So you will get one equation in terms of VA and HA. Okay, so let's say this is our first equation. Okay, so we still couldn't solve this direction at the support of our arch. Okay, so and by considering another equilibrium equation, which is a summation of force in the vertical equal to 0. So we have a VA, okay, plus VB. Okay, so minus with the all the load, okay, UDL load, which is 20 multiplied by 30 and 10 kilonewton point load. Okay, so this will give me another equation, okay, which is a second equation. Okay, so VA plus VB equal to 610 kilonewton. Okay, so and the third equation can be obtained by considering the summation of force in horizontal. So in the based on this free body diagram, so we only have a HA that acting to the right and HB acting to the left. Okay, so and this can be simplified by HA equal to HB, and you can see that I have a typing error here. This should be HB. Okay. Okay, so the value of YA here is equal to 5 meter. Okay, which is applied at the first equation. Okay, so in order to get the first equation, we need to have this value of YA. Okay, so and the fourth equation can be obtained by considering the summation of moment at point C, at the hinge. Okay, so by considering the moment at point at the hinge, okay, at the point C, so you need to consider the left hand side of a diagram. Okay, so why don't we choose the right hand side of the diagram? Okay, so they have a reason why, because you may make the solution complicated, okay, getting complicated, because if you look on the first equation, okay, so your equation are in terms of VA and HA. So if you're taking moment at the joint C and consider the right hand side of point C, so your equation will be in terms of VB and HB, which is the step will be longer. Okay, so since the first equation is in terms of VA and HA, so you need to it's better to consider the left hand side of point C, and you will get the fourth equation, which is in terms of VA and HA. So by that you can solve the first and the fourth equation simultaneously, and you will solve for VA and HE. Okay, so I hope that you can understand why you can't to consider the right hand side of point C. But if in the initial step, okay, if you're taking moment about point A, and you will get in the equation in terms of VB and HB for the first equation. So the same thing that you need to do, you need to consider the right hand side. So you couldn't consider the left hand side, because you will make it the solution getting complicated. Okay, so then by applying the equation 2, so we solve for VB, and further applying the equation number 3, so we'll solve for the HB and HE. Okay, so and the next is you can continue to solve the internal forces at the specific point. So based on the equation, so you need to solve the internal forces at the joint D, okay, and at the joint E. So let's look on the joint D first. Okay, so based on this joint D, you can see that the length of UDL include in this diagram, okay, which is from D to the support, is 5 meter only. So this 20 kilonewton per meter load only need to take into account on the 5 meter length from point D. Okay, so let's look in detail on the specific solution in this slide. Okay, so so this is a free body diagram that will be used to solve the internal forces of radial shear force, the axial force, and the moment. Okay, so as usual that you have seen in the example 1, you need to convert this UDL into equivalent of point load. Okay, so where 20 kilonewton per meter multiplied by 5, so you can see that here is 100 kilonewton point load that acting at the center of this UDL. Okay, so and as usual, you need to find out the height. Okay, so the height y. So since this is a point D, so this you can put it as a YD, and the slope, okay, or the angle, okay, theta D. And by using the general equation of a y and theta, you can see that the YD is equal to 8 meter, and theta is equal to 11.31 degree. Okay, so once you have obtained the YD and the theta, you can calculate the internal forces. Okay, right here we have a moment. Okay, so by taking moment at the cut section or at the point D, so you may to consider the VA. Okay, so which is here is equal to 278.833 multiplied by 10. Okay, so in a clockwise, and minus with the horizontal the moment due to the horizontal direction, so which is 831.667, okay, multiplied by 3 in a counterclockwise. Okay, so and also for the UDL load, okay, so 20 multiplied by 5, this will give us 100, and multiply with the distance, which is 2.5, okay, which is the distance from this point load towards this cut section. Okay, so and simplified, you can see that the moment is equal to 43.329 kilonewton meter. Okay, so and you can proceed for the axial force. Okay, so the axial force here, okay, we consider this is a positive direction. Okay, so in this directions we have n, so in a positive direction, and we have 100 sine theta, which is come from the UDL. so which is we have converted this UDL into equivalent point load, so the component is 100 sine theta. Okay, so it's also positive because the parallel with the n, and we have a negative 3831.667 cos theta, which is come from the component of horizontal direction. Okay, so and minus with a 278.833 sine theta, which is come from the component of vertical direction here. Okay, so and simplify this equation, you can see that the axial force N is equal to 850.589 kilonewton, and for the radial shear force, you need to consider all the forces in this direction. So this is a direction of positive, so and right here we have a Q, okay, plus with 100 cos theta, which is from the UDL load, okay, the component of the UDL load that we have converted into point load, and plus with the 831.667 sine theta, okay, which is come from the components of horizontal direction, and the negative 278.833 cos theta, which is come from the component of vertical direction. And simplify this, you can see that the radial shear force at point D is equal to 12.256 kilonewton. Okay, so that is for the calculation of an internal forces for UDL. Okay, let's we look on the another point, okay, which is the point E. Okay, so at the point E we have a 10 kilonewton point load that located 10 meter apart from support B. Okay, so this is a free body diagram, and you can see that in the free body diagram here we have a point load, so you need to resolve all the direction and the point load into a component, okay, which is parallel and perpendicular towards the N and Q. Okay, so as usual we need to find out the Y and the angle. So since this is a point E, so the height is denoted as a YE, which is equal to 5 meter. Okay, so the theta is equal to 21.8 degree. Okay, so once we have obtained this YE and theta E, okay, you may proceed to find out the internal forces. So as I mentioned in the early of these examples, okay, so you need to consider two conditions, so where with point load and without point load for the axial force and for the radial shear force. Okay, for moments it remain only one moment. Okay, so for the moment at a point E, so by taking moment at the cut section here, so we have VB, okay, so which is equal to 331.167 multiplied with the distance 10 meter, so which is in a positive direction. Okay, minus with HB. Okay, minus with the HB in a clockwise. Okay, so in a clockwise. Okay, multiply with a 5 meter. Okay, so and equal to M. So you can see that M equal to negative 846.665 kilonewton meter. Okay, so this is the moment for this point E. Okay, so for the axial force, okay, this is a positive direction. So in this direction we have N. We have a component of 10 kilonewton in this direction, which give sine theta. Okay, and for the direction we have this cos theta of this horizontal direction, and sine theta for this vertical direction component. Okay, so and you need to consider for the two cases, which is a with point load and without point load. Okay, so with point load you need to take into account of this 10 kilonewton in the equation. Okay, for the without point load, you need to omit this particular 10 sine theta in the equation. So for this condition, you need to consider N, okay, and the component from the horizontal direction and component from the vertical direction. Okay, so this will give you value axial force equal to 899.176 kN. Okay, so the difference between this with point load and without point load is about this 10 kN load, the 10 kN point load. Okay, so for the with point load, you need to consider this 10 kN in the calculation. Meanwhile, for the without point load, you need to omit, or you need to remove this 10 kN point load from the calculation. Okay, so the same thing for the radial shear force. Okay, so you need to calculate on based on the two cases, with point load and the without point load. Okay, so this is based on the with point load. Okay, you can see that this is a term for component of 10 kN point load. So this component from the horizontal direction. Okay, this is component from the vertical direction. And the value of radial shear force with point load is 10.655 kN. Okay, so in order to get the value of radial shear force without point load, so you need to remove this 10 cos theta in the calculation. Okay, so you may cross check this value by remove this 10 cos theta in the equation. Okay, so there is one thing that I want to highlight here on the y. Okay, so on the calculation of height y. Okay, so if you look on this slide, okay, so you can see that the x here is equal to 20 meter. Okay, so try to look on the equation. Okay, so if you look on this equation, okay, so this our point D. Okay, so the point where we want to solve the internal forces. So actually the distance from support to this point is 10 meter. So if you realize, we didn't took this 10 meter as an x. Okay, so we have considered the x equal to 20 meter. Okay, so please be careful on this particular condition if you deal with the unsymmetrical shape of arch. Okay, or in other words, if you deal with the different level of support in the arch. Okay, because you still need to consider the x from based on the complete arch shape. Okay, so since your y is at point D, so meaning that the x is 20 meter from based on the complete arch shape, not from E. Okay, so I hope that you can highlight this condition, so I don't want you to make a mistake on this. Okay, so you need to pay more attention when we deal with this case. Sometimes students make a mistake on this one. Okay, so that's all for example 2. So we will continue the lecture on the example 3 later on. I hope that you stay tuned with me. Okay, see you.